to work through all the problems. Those of you who haven't done them yet, you can come to me and look for other ones. I'm going to show you just how quickly they can be done. I've talked about before. In all reality, I'm not interested. I'm interested in you being able to do these and do these relatively quickly. There's a number of different ways. You should be able to do them 3 ways. You should be able to figure out which way is the fastest, where your skill set is, and you should be able to document. So as I'm going through this, I'm going to talk about how you can document what you've done in AutoCAD realistically by taking screenshots and explanations. I'm going to do problem 2.9, and I've done a little bit of pre-work with layers, so you'll see me doing that. So what I'm going to do first and foremost, I'm going to go to and sketch up the object in problem 2.9 by just, there's no dimensions there. You know, remember, you go to layers and you start remembering to use layer manager. Somehow I'm going to draft on the object layer. There's probably going to be more than one object layer. You see I've added some other things here: force applied, force distributed, that will be a resultant, force of reaction distributed, lines of force, moment arm, radial vector. All of these will become somewhat necessary as you use one of the tools, which is just draft it well and hit a button. So I've done that. I'm going to get rid of this here. You remember, I hope, or consider that very often the geometry of the structure will give you the geometry of the force. That said, I'm not a big lover of X lines, but I'm going to go ahead and use one in a little while. Right now I'm just going to draft an object line, hitting my format. I've gone up just some arbitrary distance here. I am going to then go ahead and turn this. I'm going to left click, spacebar, C for rotate 90 degrees, and I'm going to trim. Now I'm going to point out as I'm doing the structure doesn't have direction, because right now I don't know which line is going where. So in all reality, very often on this pole it goes all the way through. I might want to check that this structure, as I list it, is drafted in the right direction. It is going 90, so that's going in the right direction. If I think about going away and this is going 180, I might want to rotate that about its midpoint 180 degrees. Now at least I know something about the contiguity. Later on you see this actually, in this sketch, this line goes through, and then this line is actually attached by a gusset plate and it doesn't actually touch. That said, we also then potentially have a left click, spacebar, C, and we're going to rotate it 60 degrees. And this here, if you look at the 1-to-1, that should tell you it's 45, spacebar C, minus 45. You now have the structure drafted. What that structure gets you is something for the lines of force. So I'm going to go ahead and put the lines of force on there. In this case, I'm not a big lover of it, but I'm going to go ahead and put in an X line. And I don't know if you can catch that, but those X lines are X line is here. Shift right click from the endpoint of that, and I'm going to go to the endpoint of that. And the same thing there. I'm kind of drafting over the top. You don't always need to do this, but it's not a bad idea to start. Endpoint there. To the endpoint there. And if you remember this general concept of doing a window here, not wanting to grab the X lines, only that, right click and changing the draw order, which I don't have there. Display order, bring to front. So now at least my forces are there over the, or my structure is over the top there. In all reality, I don't want necessarily, right? I do not want those objects. So what I'm going to do is I'm going to go ahead and use Layer Manager, hit Layer Manager, say a new Layer Manager, and this is just the object, or the structure only, or the structure with force lines. So get used to doing this in your drawings. This is a great habit. Now it's this point in time you really don't need that, so you can go ahead and freeze, hopefully, that here. And unfortunately, we noticed there that we've also freezed out one of our, we never did have a line going straight up, so we're going to get one more X line, left click, spacebar, C for copy, 90 degrees. This gets you kind of tied into the fact that that the lines of force are infinite and go in either direction. Now you're going to start drafting your forces. You have to pick a scale that makes sense, and so you're going to draft these lines in the correct direction. You can do that any number of ways. Line from the end point here. That's not going to do it for you. You might want to go ahead and put in force applied. Line, shift right click from the intersection. And again, F8, off. You go shift right click near. If you've already done one thing, you can go nearest to that. Now, in fact, many of you know how to turn on your dynamic. Left click, and change that to 10. Great idea. Put an arrowhead on that. We'll look at how to change line types in a little bit here. So the arrow is kind of shown in the force in the line type. We've got this one here. If you want to really start the way it's drawn, you might go line, shift right click, near in this case. Right? Take it in this direction, shift right click, near. Whatever you want to do here, and then you can left click with the dynamic on, left click. That is supposed to be 12. Again, we'll have those arrows inside the line type. And the last one, of course, is a line here, which is going to be actually, you can go near. Near. And once again, with the dynamic on, left click, and making that 18. All right, now we don't have in this problem as we show it the direction of the lines of force, but we'll start doing that when we look at how we change line types. Here's the question: what is the column reacting to these forces? And so what you need to do is add these forces. And so what you do in this process is all of a sudden, if you know your ends of this, right? In all reality, you'll be able to do it just by hitting a button and having it download to R cross F, and your radial arms are going to be all about this middle point, and everything will be hunky-dory. But for now, this one goes this way. The one, remember, coming into the structure, you have to transmit. So you're going to move this one here from the end point there to the end point there. And you're going to transmit. That's using the rule of transmissivity. Grab this one there from the end point there to the end point there. Did it wrong. Move this object from the end point here to the end point there. And remember, this is a star diagram. That is something that some of you do, some of you don't. This is, in this case, this is not necessarily going to balance. What we're calculating is what is the sum of the applied forces, and so how you go about doing that is sliding them tip to tail, or perhaps listing them in terms of X and Y. The list will only work if you've drafted them in the right direction. And so I like to generally do my force diagram off on the side. I draw a little circle over here to call that the beginning. And then I just left click spacebar, C for copy, shift right click the center of that. I come back over here, I left click spacebar, C for copy. I take that to the end point, and then I go here and I left click spacebar, C for copy. Up, almost out of time. Left click spacebar, C for copy to the end point there. And our resultant then is going to be hopefully on a different level, going from the end point, no, line from the shift right click center of here to the shift right click end point of all those forces. And then it's a good idea still to go ahead and copy this one over here, go to the end point here, and that should be on some layer called resultant. At very least, you should put a double hatch on it. Now, that will be a symbol. This, of course, if you list it, it will be the sum of all those. There's all kinds of applets that do that, but these sets of drafting rules will pay off later. That is problem 5.2.9. The answer turns out to be 7.0253 at a 324.62 for its direction. Or you can get that as a unit vector times a magnitude. Thanks for listening.